A student of mine here in Udemy asked me to illustrate more about the homogeneous coordinates and how they are related to computer graphics. In the next couple of videos, I'll try to illustrate this. Let's first have a quick overview of the homogeneous coordinates. Suppose that we have some point in our 2D space. This point has A and B components. Now, what are the homogeneous coordinates? Actually, the homogeneous coordinates are a different representation for the same points. In this representation, in this original representation, the point has an x component of length A and a y component of length B, and then the point is their combination, and it is something like this. In the homogeneous coordinates, each point is represented by two parts. The first part is some sort of direction, some sort of slope, and the second part is some sort of scale. So this same point can be represented in homogeneous coordinates as something like this, for example, A over 2, B over 2, and then here we can put a third dimension, which is half. Now, what is this? Here, those two parameters say that the direction of the vector representing the point has these two components. So these two components here are something like this. So this is A over 2 and this is B over 2. So we are saying that the direction of this point is something like this. But this is not the actual point. The actual point is here. So we are giving an additional parameter here, which can be thought of as 1 over scale, saying that the actual or the real position of the real point is those components, but multiplied by this scale or divided by this whole number. So this whole number is called W, and it equals 1 over the scale. So to transform from this point to this real point, we actually perform division of these two parameters by this third parameter. So we can see that A over 2 divided by half is A, and B over 2 divided by half is B, and half divided by half is 1. So this was a homogeneous coordinate. This is another homogeneous coordinate of the same point, but note here that this is a special homogeneous coordinate that has this value 1 here. Now, why is it special? It's special because when we divide those two parameters by this 1 here, the actual value of those two parameters is the same. And actually, those values are the original real values of the point in our 2D space. So we now have this real point, this homogeneous coordinate of this point, and this special homogeneous coordinate of this same point. Now let's ask a question. How many representations of this real point in the 2D plane can we have in the homogeneous coordinates of the 2D space? The answer, of course, is an infinite number. We can have A over 2, B over 2 and half. We can have A, B, and 1. We can have 2A, 2B, and 2. We can have 8A, 8B, and 8, and so on. So we have an infinite number of possible homogeneous coordinates for this same point in the 2D plane. Actually, that's why they are called homogeneous coordinates, because homogeneous has a meaning of same or of similar or something like this, because all these points correspond to the same 2D point in the actual 2D space. The same applies if we have points in 3D like A, B, C. This is a point in our usual 3D space. If you want to map this point to the homogeneous space of 3D, we have something like A, B, C, 1. So this is valid. We can have 2A, 2B, 2C, 2, and so on. Again, this fourth parameter is called W, and it actually equals 1 over the scale of these components of the point or of the vector. Now, how can we visualize these concepts geometrically, and how are these related to our computer graphics pipeline? To answer these questions, let's create a new world for our illustrations. Here is our new world we'll be using. There are two kinds of people in this world, the lucky people and the sad people. The lucky people are those who can live in the 3D world and can perceive 3D, can perceive the X, Y, and Z components of the space. A representative for those is this guy here, which I will be calling Lucky Fatih. While the sad people are people who are living in this 2D plane and they cannot perceive 3D at all. They cannot recognize 3D. Just as the lucky Fathi cannot recognize 4D because he lives in a 3D world. So a representative for the sad people is some person here and he is called sad Fathi. So this said Fathi can only view things inside his 2D plane and he cannot at all perceive the third dimension, he cannot imagine it, just as Lucky Fathi cannot perceive the fourth dimension. Despite the fact that Lucky Fathi could not perceive the fourth dimension, he was able to use it before in doing his translational transformations. In the same way, Sad Fathi does not recognize the third dimension, but he can use a third component to do his translational transformations inside his 2D plane. Okay, now how does this relate to our overview of the homogeneous coordinates? Suppose we are inside this plane here and we have some 2D points. Suppose we have the point, for example, 1, 2. So this point is move 1 in the x direction and then move 2 in the y direction inside this plane. So we have something like this. This is the point 1, 2. Since this is the real point 1, 2, if we wanted to transform it to the homogeneous space, we can actually say that the third component of this point is 1. This is the W component of this point because, as we have said before, when the W is 1, then these are the real values. Said Fathi, being a computer engineer, realizes why algebraically he has to put this 1 here, but he does not realize what this means geometrically, and that's what makes him really sad. Lucky Fathi, on the other hand, realizes what tortures the soul of sad Fathi. He understands the whole situation, but he is unable to explain to sad Fathi what he understands because this is beyond the imagination of sad Fathi. Lucky Fathi realizes that this third component sad Fathi has put into his point actually is a translational component into the Z direction that only Lucky Fathi can see. So what Sad Fathi recognizes as the magical W component is actually the same as the Z that Lucky Fathi recognizes as the third dimension in his own world. So actually Lucky Fathi realizes that the whole plane that Sad Fathi lies in is actually one step from his own origin here in the Z dimension, which Sad Fathi cannot recognize. So this whole plane lies one step from this origin in the Z direction. Now in this configuration, what do the homogeneous coordinates of this same point mean, or what do they represent? In order to know this, let's get some examples of some homogeneous coordinates of this same point. Let's have, for example, 2, 4, 2. Let's have 3, 6, 4. And also let's have 1 half, 1 and 1 half. So all these points, when divided by their W component, will correspond to the same value of 1 to 1. So these are homogeneous coordinates of this same point. Now, what do they represent geometrically? As we can see easily, these points all lie on the same vector. They all have the same direction, the same slope. Actually, if we draw this as a vector like this, we see that all these points lie on this same line. For example, 2, 4, 2 will lie somewhere like here. 3, 6, 4 will lie something like here, and one half will be somewhere, let's say, here, be behind this plane. I think it is getting clearer now why are those 4 points considered to be homogeneous. Those 4 points are considered to be homogeneous because if they are projected along this vector onto the plane where Sad Fathi lies, they will all be projected onto the same point, which is 1, 2, 1. This projected on this plane along this line will correspond to B here, and this will correspond here, and this will correspond here. All those homogeneous points will correspond to the same projected point on this plane where Sad Fathi lies. So this gives us a hint about the relation between the homogeneous coordinates and projection. We will build upon this relation in the next video to illustrate the real relation between projection and homogeneous coordinates, but it's better to keep this in mind. A final note here is while Lucky Fathi realizes the problem that Sad Fathi faces with his homogeneous coordinate, he also realizes while he can solve Sad Fathi's problem, he cannot solve his own problem. Lucky Fathi on his own cannot understand the meaning of homogeneous coordinates in his space. When he types something like x, y, z, and w, this w is not the same as Sad Fathi's w. Sad Fathi's w is this z, while this w is another component in a 4D space that Lucky Fathi cannot perceive, just like Sad Fathi cannot perceive the 3D space that Lucky Fathi lies in. Lucky Fathi can use this W component mathematically or algebraically, while he cannot understand the geometrical meaning of it because it is beyond his own imagination. So now we have finished this first point, the quick overview. In the next video, we will consider this second point using the same world we have created here.